This lesson looks at sequences, so we're going to look at arithmetic sequences and geometric sequences. Starting with an arithmetic sequence. In an arithmetic sequence, each term is determined by adding the same value each time. So here's an example of an arithmetic sequence. If you have 2 minus 4 minus 10 minus 16 comma dot dot dot, that's an example of an arithmetic sequence. First of all, in a sequence, the terms are separated by a comma. The other thing you'll notice is in order for it to be an arithmetic sequence, then there has to be a common difference, which means each of the terms have a difference between them that's exactly the same. So for example, to get from the first term to the second term, I would need to subtract 6 or add -6. To get from the second term to the third term, I would need to subtract 6. And the third term to the fourth term, I would need to subtract 6. So because the values that I need to add or subtract to get from the first term to the next, etc., are the same, this value here is called the common difference. Okay, that's what makes it an arithmetic sequence. It has to be a number that you're adding or subtracting each time to get to the next term. Okay. The general term formula for an arithmetic sequence looks like T of n equals a plus n minus 1 times d. And what this means is, if you know what this general formula looks like, then you should be able to find any term in the sequence. Okay? T of n represents the nth term. A represents the first term in the sequence. N represents a number of terms in the sequence. And d represents the common difference. So for example, if I wanted to know what the 20th term in this sequence would be, I could either sit here and continue the pattern all the way up to the 20th term, or I can recognize that I can come up with a general term formula and use a general term formula to help me determine the 20th term. So I can come up with a general term formula for the sequence. So if I wanted to figure out what the formula would be for a sequence that looks like this, what I would do is first recognize that my first term is equal to 2. The number of terms, well, I don't know what the number of terms are that I'm looking for, so that's going to stay as n. And d, which is a common difference, is what the difference is between each of the terms to get from the first to the next, etc., etc. So the common difference in this case is -6. So if I wanted to write the general term formula, I would just plug in the numbers I know. A is equal to 2 plus n minus 1, and d is equal to -6. And I'm adding brackets around the -6 to indicate that I'm multiplying here. And you can actually simplify the general term formula, which is always a good habit to do. So 2 stays the way it is for now. -6 times n is -6n, and -6 times -1 is +6. And so I can simplify the general term formula here as -6n plus 8. So what that means is, if I wanted to find any terms in this sequence, all I need to do is plug in the term number, and then I can solve for it. So for example, if I wanted to check if the fourth term is correct here, I would plug in n equal to 4, and so I would get T of 4 equals -6 times 4 plus 8. So wherever you see an n, you would replace it with the number that's in the subscript here. And so I get -24 plus 8, which is equal to -16. So I know that the fourth term is -16. And using this formula here, you should be able to figure out any of the terms in the sequence that you have here. So that's an example of an arithmetic sequence. Okay, common difference, and so you know it's arithmetic. Geometric sequences are a little bit different. In a geometric sequence, you have a ratio that's common, so you're multiplying to get from the first term to the next, etc. So in a geometric sequence, each term is found by multiplying the same value each time. This value here is known as the common ratio, as opposed to a common difference. The general term formula looks like T of n equals a times r to the exponent n minus 1. And in order to find what the common ratio is, instead of subtracting to find the difference, you would divide to find the ratio. Okay? So T of n represents the nth term, a represents the first term, r represents the common ratio, and n is the number of terms in the sequence. Here's an example of a geometric sequence. So if I had 2, -6, 18, -54, etc., this is an example of a geometric sequence. One way to determine that is because you know that the difference between 2 and negative 6 and negative 6 and 18 are not the same. That's how I know it's not arithmetic. And so, but if I look at how to get from the first term to the second term, I would multiply by negative 3. From the second to the third, I would multiply by negative 3. From the third to the fourth, I would multiply by negative 3. So what that tells me is negative 3 is my common ratio. That's what I need to multiply each time to get from the first term to the next. So if I wanted to write a general term formula for this one, first of all, I have t of n equals a times r to the exponent n minus 1. And I know that a is equal to 2 in this case again. And r is equal to negative 3 in this case. So all I need to do is plug in these two numbers into the general term formula. I don't need to know how many terms I have right now. That's only if you wanted to solve. And so there's my general term formula for the geometric sequence. Please be careful. When you are looking at a geometric sequence like this, you cannot multiply 2 times negative 3. And that's because the negative 3 has an exponent applied to it first, which you would need to evaluate before you multiply it by 2. Remember, your order of operations still apply here. Okay? So if I wanted to look for the third term, and I know I already have the third term in the sequence, but let's say I wanted to find the third term. That would mean n is equal to 3, so I'm changing the subscript to a 3. And I would plug in 3 into the formula here, so I would have 3 minus 1 in my exponent. And so that would give me 2 times negative 3 to the exponent 2. That's 2 times 9, which is equal to 18. So I know that the third term would be equal to 18, and that's what I have here as well. So we're going to look at a couple more examples of arithmetic and geometric sequences, and the idea here is to figure out which sequence you have and be able to go with it from there. So our first example says the first term of an arithmetic sequence is equal to 6 and the common difference is equal to 3. Find the general term formula for the nth term. So I'm told that the first term is equal to 6 and the common difference is equal to 3, and so what that tells me is my value of a is equal to 6 and my value of d is equal to 3. In the first part of the question, it just asks you for the general term formula. So I'll start with the general term formula for an arithmetic sequence, since it does tell me it's an arithmetic sequence. So it looks like that. And now I'm going to plug in the information that I know. I have t of n equals 6 plus n minus 1 times 3. And so that'll give me t of n equals 6 plus 3n minus 3, and so my general term formula is 3n plus 3. Okay? For this particular sequence. And then it says find the value of the 50th term. So if I want to know what the 50th term is, then this means that this is a value of n that's given. So n is going to be equal to 50. And so if I try to find the 50th term, I'm going to replace n with 50. And then just evaluate it from there. So I get the 50th term is equal to 153. Okay, so you can either sit there and start the pattern and say, okay, the first term is 6. And then because the common difference is 3, it would be 6, 9, 12, 15, dot, dot, dot. You can continue this pattern all the way up to the 50th term, or you can use the general term formula and that'll tell you what the 50th term is right away. Okay, second example asks us to find the 10th term in the following sequence. So you'll notice in this case, I don't know which kind of sequence we have. So we have to determine whether it's arithmetic or geometric. And so if you look at it, I start with 2/3 and then it goes to negative 2, which means this is increased by 2 2/3 if I'm trying to find the common difference. So this is increased by 2 2/3. Then it increases by 8. Right away, because the common difference is not the same, I know that this is not going to be an arithmetic sequence. So I can scratch that out of the idea here. Let's check if it's a geometric sequence, which means I'd need to find a common ratio. So I need to figure out what I can multiply the first value by to get to the second value. And I know I can multiply this by negative 3. So 2/3 times negative 3 will give me negative 2. Let's see if it's the same here. If I multiply by negative 3, yep. And if I multiply by negative 3 as well. Okay, so what that tells me is that I have a geometric sequence and that the common ratio is negative 3. So I can write my formula. A is going to be equal to the first term, which is 2/3. And R is going to be equal to negative 3. And my In order to figure out the 10th term here, I need to come up with the general term formula and then plug in n equal to 10. Okay, because I am looking at the 10th term. So let's start with our general term formula. So a times r to the exponent n minus 1. And so that gives me 2 over 3 times, and I'll put this in brackets again, negative 3 to the exponent n minus 1. And now because I am looking for the 10th term, I would do t of 10 equals 2 over 3 times negative 3 to the exponent 10 minus 1, which simplifies to 2 over 3 times negative 3 to the exponent 9. And I'll continue that up here. And if I simplify this, this is 2/3 of negative 3 to the exponent 9 is equal to negative 19,683. And 2/3 of that is equal to negative 13,122. So there's the 10th term of the sequence.